Okay. One thing that you want to be very, very discerning as you study or as you read statistical study. And by the way, when I say statistical study, I'm not talking just about, the technical studies. If you read a journal article, or if you read, somebody quoting some study on Facebook or some kind of social media, you will see that there are many statistical studies. Some of them are carefully done, some of them aren't. Okay. You could just read a sentence like 70% of Americans agree with this position or something, right? And then you ask this question here: what type of study was done? Were there loaded questions asked? And who was in the sample? What kind of a population are they referring to? So these are the questions that you want to ask as you look at these claims based on, or supposedly based on, statistics. All right. One of those important questions is the type of statistical studies. What kind of a study was done, right? And so the first type is called observational. You will have questions in your homework classifying, what type of statistical study was done in this situation. An observational study is where researchers just observe. They measure, they collect data, but they do not influence anybody in any way. That is the important thing here. Now, no influence. So the observational study is one where, for instance, no drug is given, no treatment is done, no music was played if that's what you're trying to study or something, right? There was a science project by a student who was saying what kind of music would help plants grow the most, classical or rock or jazz or whatever. Well, see, that's not an observational study because you're actually trying to influence the growth of a plant or growth of plants by playing different types of music, right? Okay, so that's an observational study when all you do is to measure or collect, right? What is the average height of all Americans? All you do is to collect data, right? You are not trying to stretch people. You're not trying to shrink people. That's an observational study, right? And the opposite of observational study is experiments, statistical experiment, right? So these are scientific experiments. The group is divided into at least two groups, maybe more. A treatment group, and this group is given treatment, okay, and a control group, and this group is not given the same treatment, maybe no treatment at all, okay? And this is to study the effectiveness of some treatment, okay? This is a very big topic today, right? As companies are trying to come up with vaccines and so on. And so how do you do that? Well, you have to divide the subject or group, in this case, a group of patients, into a treatment group and a control group, right? Now, for the control group, sometimes you don't have to do anything, okay? But a lot of times, and here's a key word, okay? This is a word that everybody needs to know, especially in our days. Placebo. Okay, what in the world is a placebo? Okay, a placebo may be given or used, and that's a fake pill. All right, now participants, interesting. What is this fake pill? Well, the thing is, the control group, you may not know these people in control group that they are not getting treatment, okay? And in fact, sometimes just the knowledge that they are getting treatment or not getting a treatment, that knowledge could psychologically affect the patients, right? And there are many situations where people are given fake pill and say, this is going to cure your headache. And sometimes, for some reason, sometimes these things actually work, right? And so just the psychological effect of people getting better is called the placebo effect. And in order to avoid that, you actually divide the team or a group of patients into a treatment group and a control group. And the treatment group actually get the real thing, and the control group will get a placebo, right? And so the idea of this placebo effect, I will try to write down and type up the definitions later, okay? But you have to avoid the placebo effect. And so that's one thing that we have to be careful about. All right, now, when you use a placebo, a fake pill, and often it's just like a sugar pill, or a pill just contains water, no active ingredient, okay? So maybe I should say that. It's a no active ingredient. It could have, an ingredient. It just doesn't have that ingredient found in the real treatment. All right. Now, the participants don't know who belongs to which group, obviously, right? Because, I mean, if you knew that, hey, you were being given the fake pill, that would sort of kill the purpose of getting that fake pill, the placebo. So the participants don't know who belongs to what group, okay? And in this case, if only the participants don't know which group is being given a fake pill or a placebo, this is called a single blind test or a single blind experiment. Okay, so what do I mean by that? All right, so here's an example. You have a treatment group and you have the control group. Okay. Now remember, these people in the treatment group are given real medicine. All right. Let's say this is a drug that's supposed to cure you of a certain disease. The control group is given a placebo. All right. And if the doctors giving the treatment, these pills, okay, the researchers, they know which subject or which patients belongs to which group, but the patients don't know. That's called a single blind experiment because these people do not know. Okay, but sometimes, okay, now imagine these people, all of these patients will be examined by a doctor or whoever is doing the research, right? And sometimes the doctors could also get biased. All right, let's say these people are given a new antidepressant. Okay, and the control group is given the placebo, and they think they're taking antidepressant. And by the way, in these studies, often every person participating in the study will be given a waiver saying, we would not tell you which one you're taking. You may be taking the real treatment, you may be taking a placebo. That's the nature of these studies, experiments. Right? Now, the doctors are going to evaluate how effective or how effectively the new antidepressant is working on these groups, right? Now, the doctors could also be biased. If the doctor knows, okay, if the doctor knows that these people are taking a placebo and there's no way they could be getting better, right? And then they come to examine and say, yeah, you know what, your depression is not getting better, okay? But this group, the treatment, the doctors think that these people should be getting better. So this bias on the doctor's side, they may think that these people should be getting better and they may give better evaluation. So in order to avoid that kind of bias, okay, on the part of the examiner, sometimes these people are not told which patients are getting the treatment and which patients are getting a placebo. Okay. You get that? Right. So in order to avoid the bias on the part of the evaluator, sometimes neither the participants nor the evaluators know who belongs to which group. Okay. In this case, we call this a double blind experiment. And this is the most expensive because you have to, whoever is doing the study has to keep this secret from the doctors, the evaluators, the assessors, and the subject, the patients. Okay. Now somebody's actually keeping track, right? Obviously, each of these subjects, each of these patients are given an ID number, and we know which one, but doctors don't know. But whoever is conducting the research, the administrators know which patients belong to what group, but they would not tell the examiners or the evaluators. And this is called a double-blind experiment. And sometimes you would have to go this much into this much trouble in order to have an unbiased result. All right. So this is, for instance, in the trial of a new antidepressant. Okay. Or maybe they're trying to examine, I don't know, some kind of a skin condition or something where the doctors have subjective opinions about things, okay? So in this case, that would be called a double blind test. All right, so far, what do we have? We have observational study, that's number one. And number two is experiments. And under experiments, you have single blind and double blind. Okay, so sometimes So hopefully that's clear now, right? So basically 2 types of statistical studies. About to give you a 3rd type, but the first type was observational, where no influence given, no treatment is given. Number 2 is the experiments where treatment is given, but in that case, you would have to classify, or you would have to divide the sample into 2 parts, treatment group and control group. And definitely a placebo is going to be used in experiments. All right, sometimes a placebo is impossible. You just can't have an equivalent of a fake pill. All right, so here's an example. Can jogging prevent sickness? All right, and that's a good, good topic, right? And when people jog, does it keep them healthy? Does it keep people from getting sick? What kind of a placebo are you going to use? Okay, are you going to make people think that they're actually jogging when they aren't? It's really hard to come up with a fake pill that fools them into believing that they're actually getting this jogging effect. Does the use of computer improve children's learning? Okay, I guess you can try to come up with a fake computer, but a placebo is very, very difficult, if not impossible, in a situation like this. So just understand that sometimes a placebo is possible, sometimes a placebo is not possible. All right, and then the 3rd type that I was referring to here, this number 3, and the 3rd type of study is called a case-controlled study. Now, what in the world is a case-controlled study? All right. This is where the participants freely choose which group to be in. Okay, now here's an example, and I hope these examples help you understand this. All right, does alcohol affect pregnancies? Okay, alcohol probably does affect pregnancies, and pregnant women should certainly not drink alcohol. All right, but of course, I mean, is that true? I mean, how do you know that? Well, one thing you can do is, one thing you cannot do ethically is to give a bunch of pregnant women alcohol and say, all right, I'm going to give you fake alcohol or real alcohol. No, you can't do that. Right? So for certain ethical reasons, some studies are not possible. Okay, some studies are not possible as an experiment. Okay, you cannot randomly decide to give certain pregnant women treatment and certain pregnant women placebos. But you know that there are, people, pregnant women, who choose to drink alcohol. And so you can study the effect of alcohol on these people because you're not making them, but they are freely choosing to take that treatment, in this case of the alcohol. And then you can do the study and compare the pregnant women who drink alcohol and people who don't. Okay, so that would be called a case control study. A case controlled study is a study in which you have 2 groups of people, the people with the treatment and people with the control without the treatment. But you, as researchers, do not choose them. They choose themselves. So participants freely choose which group they belong to, and then you do an observational study. Okay, so this is sort of like a mixture of an observational study and an experiment. It is an experiment in the sense that you are comparing 2 groups, but it is observational in the sense that you are not dividing people into these 2 groups. Okay. Do seatbelts save lives? Okay, well, most people do believe that. Some people still don't. How do you prove that? Okay, again, you get 100 drivers and you randomly choose 50 of them to wear seatbelts and the other 50 not to wear seatbelts. No, you can't really do that, again, for ethical reasons. But there are people who choose to wear seatbelts and there are people who choose not to. And you can do a comparison between those classes of drivers. That would be a case-controlled study. Do drugs kill brain cells? Okay, so you give a half of the subjects drugs and the other half placebo and see if their brain cells are killed. Again, you cannot do that ethically, but there are people who choose to use drugs and people who choose not to, and you can do a comparative study on those. That would be a case-controlled study. All right, one very, very important statement here, and I cannot emphasize this enough. This is one of the main takeaways from this entire course, okay? And we already talked about this in the very first lesson. This is one of the fallacies It's called a correlation/causation fallacy. The point is, okay, just because there's a correlation between A and B does not mean that A is the cause of B or B is the cause of A. Another way of saying this is an observational study, and any observational study can never establish cause and effect. Get that? If a study is an observational study, that cannot establish cause and effect. Just memorize this statement if you want to. And just think about this all the time. This is an extremely important statement. An observational study can establish correlation, okay, a relation. Sometimes it's referred to as an association between two things. Okay, so for instance, one's height and weight, okay, it turns out that the taller the person is, the heavier the person tends to be. Not exactly, but there is some correlation between this and this, right? I mean, if you have somebody who is really short, like a child, usually children weigh less than a fully grown adult. So there is a correlation, an association between height and weight, but that does not mean that the height is the cause of the weight or the weight is the cause of the height, right? The weight of the car and the fuel efficiency, okay, these two things are related. These are associated with each other. Heavier the car is, the less fuel efficient the car is. Okay, so does it mean that the weight is the cause of the fuel efficiency? Or does it mean that the fuel efficiency is the cause of the weight of the car? And you cannot establish any causal relation. That may be true, okay? You just cannot claim that, all right? So, and I will be typing up some of these things here. Let me explain what I mean by this. Okay, this is, again, these are real studies that may claim something, and I want you to be very careful, and I want you to exercise your critical thinking and observing what's wrong with these statements, okay? Children with older moms do better in school, okay? So this was one of the findings, and it's been consistently true in many studies. Children with older moms do better in school. All right, think about this idea. It seems like the mom's age and the academic performance of the child are related to each other. There's definitely a correlation, association. Older the mom, so you can even graph this, right? So this is mom's age. And this is the kid's GPA in school, right? And you know, you can take a bunch of people and you see the positive correlation as the as the mom's age gets older, or the older the moms are, the better the kids' GPAs are. How do you make sense of this? Notice here, this is an observational study. Get that? This is an observational study. So you cannot claim for sure that the mom's age is the reason for students doing better. Okay, in other words, the older moms cause the kids to do better in school. That wasn't the case. Okay? And of course, you can't do the opposite. You know, if you do better in school, that will make your mom older. That's not true either. Right. So after further studies, what sociologists have discovered is, yes, sure, there is a correlation, but there is an underlying cause. Okay, so this is another important term that I should mention. There is an underlying, maybe I should say common underlying cause that would explain both of these. Okay, in this case, there is another reason or another factor that is causing the moms to be older and the kids' GPA to be getting higher. Yeah. And what they have found is that it's basically the mom's education level. Okay, so these older moms tend to be the ones who are more educated. In other words, if a woman goes to college and perhaps graduate school, many times they wait until they get older to become moms, right? And these moms, because they are educated, they emphasize or focus on studies at home, and the kids do well in school, right? Get that? So it's not the age that's making the kids smarter. There's an underlying cause, common underlying cause, basically the mother's education level, that is causing the age to be, the moms to be older and the GPAs of kids to get higher. So this was the mystery, right? So again, observational studies cannot establish cause and effect. Okay, here's another example. This is during April 2020. People were driving faster and there are fewer accidents. Okay, there was a classic correlation. During this time, people are driving faster and faster, and there are fewer accidents. Does it mean that the high speed is causing fewer accidents, or does it mean that the fewer accidents are causing people to drive faster? Okay, the answer is no. I mean, there is clear correlation or association, but one is not the cause of the other. Okay, the reason people are driving faster and fewer accidents are occurring, remember, there was an underlying cause, which was basically the society's shutdown, right? People were asked to stay home unless there is an absolute necessity. And so as a result, because most people are staying home, there were fewer accidents on the road. And because there are not too many people on the street or on the freeways, people are driving faster. Okay, but this correlation does not establish any cause that the higher speed is causing fewer accidents. And I hope people don't believe that. All right, and then finally, the sales of a new toaster increased as more people attended concerts. Right? Again, this is true. Right? So there were times, and people, you can go back in history and study this, whenever people attend more, in fact, this is more of a classical concerts, when people attended more concerts, the toaster sales increased. Okay, strange, right? Can you explain this? What explains this correlation? The increase in toaster sales and the more attendance in concerts. Okay, again, there's a common underlying cause, right? And this happened whenever the economy got better, right? So people are getting more money, and so as people have more money to spend, they can buy things like toasters. And by the way, a bunch of other things, the sale of new cars increased, and sales of many other things increased at the same time. But the good economy is causing this and this. But this is not the cause of this, and this is not the cause of this. Okay, that's what you have to remember. All right, so if you go into your homework, there are some graphs and charts that you are to make sense of. And so, and I'm not going to really talk about these things because these are pretty obvious, but pie charts, you have charts that are divided up and add up to 100%. That's a pie chart. You have these bar graphs like this, you have line graphs, and you have histograms where these numbers are, this is a continuum. And so these histograms are like bar graphs, except they're right next to, the bars are right next to each other, right? One of the things I should mention is among the tables and charts, okay, there's a thing called the frequency table. Okay, this is pretty easy to do this. But here's an example. How many times have you visited New York City? And let's say all these people answered the question this way. No, but 0 times, 2 times, 3 times, and so on. Okay, so what you can do in order to summarize your result is like this. You can write, or you can draw or construct a frequency table. 0 was the answer for how many people? 1, 2, 3, and 4, right? So you can write, the number is 0, the frequency is 4. So the frequency is the number of times the particular answer occurred. How many people said 1? It looks like 2 people said 1, right? Oh, no. 3 people said once. They've only been to New York City exactly once. How many people have been to New York City twice? 1, 2, 3. So again, 3 people said that. So the frequency is 3, right? And then how about the answer of 3? You have 1, 2. So 2 people said 3. And then 4, nobody said 4. Nobody said 5. But 6, there's one person who said 6. And then 7, 8, 9, nobody says 7, 8. And then there's one person who has been to New York City 9 times. So that's only 1. Okay. So this is called a frequency table. Now it's really not that hard. This is more of a common sense thing to do. And so I think you are asked to construct little charts and tables and frequency tables and so on. And but we will not spend too much time on these this kind of a descriptive statistic, right? So the whole idea of this particular lesson was to learn these important concepts and terms. And I hope you understand many of these terms, all of the terms, and the ideas. Okay, so this is chapter 12. You notice that I didn't do any calculations, right? There were some numbers involved, but lots of lesson 12 is basically these fundamental terms of statistics. And so make sure you review all the words that were introduced, like parameters and population and sample and different types of sampling and bias and so on. And as we go into the next two sections, the next two lessons, these words will become very important. And as you read things on the computers, on your social media, on the papers, on the articles in the journals and so on, okay, people claim to say a lot of things, and then they bring lots of data, right? So start asking these questions for your critical thinking, like who is writing, what type of study was done, was the population well represented? Is there any bias? Okay, these are some of the critical things that you should be looking for as you study or as you hear and read people's claims. Okay, that way you can find the truth and not fake news. Right. So, all right. So I will see you when we go into lesson number 13. And until then, have a great day. I'll talk to you later. Bye.